And welcome to Keystone Tutoring. Today we are going to be furthering our knowledge of differentiation. In the previous episode of differentiation, we sort of introduced it, what it means, and gave some very basic examples. Today we'll be going into these three examples here: the product rule, the quotient rule, and chain rule. Just a quick, brief reminder that differentiation is just the instantaneous rate of change, which we defined in the last episodes, and I do highly recommend you do watch the last episode too, if you have not already, to have continuity of understanding of what we are doing. Awesome. So let's get straight into the product rule. So the product rule is can be described in this formula here d over dx of u of x times v of x is equal to this here. So let's break this down. So d over d of x means we are differentiating with respect to the parameter x. So whatever's on the bottom is what we're differentiating with respect to. U of x and v of x, you may be a bit confused, but these are just simply two functions. So this could be literally any two functions. And we'll go into two examples of when to use the product rule and when not to use, just as we can see below. But before we do, let's just break it down. So when we have two functions with the same parameter, in this case x, just for simplicity, we use the quotient rule in general. So as we can see here, u of x times v of x, and then we can separate into this. So the first derivative of u of x times the v of x as it was given to us, plus the u of x as it was given to us times the first derivative of v of x. So let's go into two examples of when to use and when not to use. I will start with when to use the product rule. So we're given the question, differentiate x squared times sine of x. It might be a bit more clear as to why we're doing this because x squared times sine of x doesn't, you can't just sub in the x squared and the x and make sine of x cubed. It doesn't work like that. They're two separate scenarios here. So let's define it. So we know we have to have a u of x and a v of x. Let's say it can be either one, but let's say u equals x squared and let's say v equals the sine of x. And we want to find the derivative of this multiplication. So then the next step would be is to find the first derivatives of each, as we can see here. And that for u of x, as we've seen in the last episode, is simply 2 of x. And we haven't covered this yet, but I will in a following video. But there is some rules in regards to derivatives of sine, cos, ln, exponentials, things of that nature. And just to let you know, if you have sine of x, the derivative is always cos of x. If it does have, let's say, sine 2 of x, it will vary, but we'll meet that again in a future video. Awesome. So now we have everything we need. So we can find the derivative by simply plugging everything into the formula given below. So u dash of x we established to be 2 of x, v of x we established to be sine of x, so we can do 2 of x times sine of x, plus here the u of x, which we said was x squared, and times that by v dash of x, which we said was cos x. So simply our derivative to x squared times sine of x is 2x sine of x plus x squared cos of x. Awesome. When not to use the product rule? You can use it in this scenario if we have u of x equals 3x squared and v of x equals 2x squared, but you'd be wasting your time, to be honest with you. Because as we can see here, x cubed times x squared, we can times that by one another to make one simple fraction, right? And we can just make it into 6 of x. 3 times 2 is 6. X cubed times x minus 2 is x to the power of 3 minus 2, which is simply just 6x to the power of 1. And we can do that straight away. We know just drop the x and we get 6. So you can do it in this scenario, but you'd be wasting time. And it's better just to do that. But in cases where you can't multiply the parameters together, as can be seen here, you will use the product rule. Awesome. Now we are moving on to the quotient rule. The quotient rule is pretty much the exact same principle as the product rule, except this time instead of multiplying, we are dividing. So let's look at the formula here. We have d over d of x, so once again, differentiating with respect to x of the function u of x. I might make that a little bit more clear. That's u of x over v of x. u of x over v of x. So just the two functions once again. And simply we find the first derivative of u times it by the initial function of v minus the initial function of u times by the first derivative of v all over v squared. Remember, we have to square this. So let's get straight into an example to make it clear. So we have f of x equals ln of x over x cubed. All right, so the first thing we always do is we got to say what's u of x, what's v of x. In general, the quotient rule, it doesn't matter which one you assign u of x and v of x to. U of x is always the numerator and v of x is always the denominator. So u of x here in this case is ln of x and v of x is x cubed. Let's find u dash of x and v dash of x. So u dash of x, as I said before, we have special cases with ln exponential and everything. And just to let you know, if you ever say ln of x, its derivative is always 1 over x. But we'll go back into this into a future video. And then v dash of x simply is x cubed. So as we learned from the principles in the first video, that is simply 3x squared. So now let's plug this all in to find the derivative. So the derivative of f of x, as can be seen here, is we get u dash of x, which is 1 over x, times it by the initial function of v, which is x cubed. So 1 over x times x cubed, we minus it this time instead of plussing with the original function of u, which is ln of x, times that by the derivative of v, which is 3x squared, and then all over the v squared, so x cubed squared. Let's just break this down. X cubed on x minus ln of x, 3x squared, 3, and then this is just simply 3 times 2. So then let's just break it apart. X cubed on x is just simply x squared, and then we divide that by x on 6 minus ln of 3x squared. So the squares cancel, and that just becomes 4. And then finally, we get 1 minus 3 ln x on 4. And that is our derivative to ln of x on x cubed. Awesome. So now we are on to the last section of this video, which is the chain rule. So the chain rule is very interesting. So let's say we have a function f of x here, but within that function, we have another parameter, another function within it. So we are differentiating a function when it has a function within it. We'll get into two examples to make it very clear what we mean by this. But simply, this thing here, the derivative of a function which has a function within it in respect to x is simply the derivative of the outer function, f of x, keeping the inner function the same, times the derivative of the inner function. Okay, so it may be a bit unclear, but as soon as we go into examples, I believe it will become more clear. So the first example we have here is differentiate sine of x squared. So we have what, let's say what it is. The outer function, sine, is f g of x equals sine of x squared. That's our outer function. But our inner function here, g of x, the inner function is simply x squared. Awesome. So what did we say? We have to find the derivative of the outer function and the derivative of the inner function, while reminding that the derivative of the outer function, we keep the inner function the same for that one. So f dash of x of g of x, as we said before, the derivative of sine is cos. So it's cos here, but we keep the inner function the same. So only apply to the outside function. Keep g of x the same for the f dash g of x. But then when we come into g dash of x, the inner function, that's simply x squared. So the derivative of that is 2x. So simply putting it all together, the outer function cos of x squared, and we times that by 2 of x, and that is our derivative of sine of x squared. Awesome. Now we'll go into a bit of a different example. 3x plus 5 to the power of 4. All right. So you may be thinking, interesting, would we expand this, do 3x plus 5 times 3x plus 5 times 3x plus 5 times 3x plus 5? You could, but that would take a lot of time, and it's just not feasible. What we instead do is assign the outer brackets to be our greater function. So fg of x is just equal to the 3x plus 5 to the 4. And 4 here is our interest. And our inner function is simply 3x plus 5. So when we do the derivative of the outer function, keeping the inner function the same, we get the 4 here as I normally would. You could think of this, you can think of the 3x plus 5 as x. So to sort of simplify it, let's think of the 4 3x plus 5 here. Let's think of this whole thing. Sorry, not there. Let's think of this thing here simply as x to the power of 4. Let's just think of it like that. The inner function, we're always going to keep 3x plus 5 to the 4. And we know the derivative of that is you take the 4 down, you go x, keep x the same, 4 minus 1. So simply it's 4x cubed. But what is x? X is our g of x. We keep that the same. So we sub in the 3x plus 5 here, and we get 4 times 3x plus 5 to the power of 3. Awesome. So now we go to our inner function, g 3 of x plus 5, and that's simply the derivative is 3. Remember, if a part of the function 5 here does not have an associated parameter, it's just the numerical value, that will always go to 0. So now let's find the chain rule. Let's go back. It was the derivative of the outer function, keeping the inner function the same, times the derivative of the inner function. We established the derivative of the outer function to be 4 3x plus 5 to the power of 3, and the inner function to be 3. So simply 4 times 3 is 12, and the remaining is 3x plus 5 cubed. Awesome. So that comes to the end of the video. I hope we provided some clarification to any questions you've had, and best of luck in your studies.